We'll start with the exercise 10.3, third sum. Here in third sum, we are asked to reduce the following equations into normal form. You have to convert this into normal form, and you have to find their perpendicular distance from the origin and the angle made by that perpendicular to the positive direction of x-axis. Right. These are the two parameters that we get from the normal form. So you have to convert the given equation into normal form. So let's try to understand the very first equation. See, if we want to convert this given equation into normal form, then we will take this constant towards right hand side. So using transposition, I will take this plus 8. As this represents the perpendicular distance, this should not be negative. So if your constant is negative, then you should make it positive by multiplying with minus 1. Now, we will divide the equation with square root a square plus b square, that is square root minus 1 whole square plus root 3 whole square, where a is the coefficient of x and b is the coefficient of y. So I will get 4, that is, so I will divide this whole equation by 2. Now, on comparing with, we will compare with uh, x cos theta plus y sin theta is equal to p. So I will get p is equal to 4 cos theta as minus 1 by 2 and sin theta as root 3 by 2. So I got the perpendicular distance from the origin, but they are asking us to find the angle also. So here cos theta is minus half and sin theta is root 3 by 2. As cos is negative and sin is positive, my angle is in second quadrant. And if it is in second quadrant, I should write it as pi minus. Now, cos becomes half at 60 degree. And if you consider this also, then also sine becomes root 3 by 2 at 60 degree only. So my angle will be 2 pi by 3. So here we were asked to find two parameters, that is, one is the angle and another is the perpendicular distance. So let's try to understand the second equation given. Here the equation given is y minus 2 is equal to 0. So I will take a constant over here and I will write this as 0x plus y is equal to 2. Now we will divide this square root a square plus b square, 0 square plus 1 square, that is 1 only. So if it is 1, no need to divide it with 1. So this will be my equation. So I'm comparing with x cos theta plus y sin theta is equal to P. I will get a perpendicular distance as 2 and my cos theta will be 0, sin theta will be 1, and I know that at pi by 2 my sin is 1 and cos is 0. So angle made is pi by 2, whereas the perpendicular distance is 2. Let's try to understand the third question of this third. The given equation is x minus y is equal to 4. You can see that my constant is on right hand side only and it is positive. So directly we will divide the equation with square root a square plus b square, that is 1 whole square plus minus 1 whole square, that is root 2. So 1 by root 2 x minus 1 by root 2 y is equal to 4 by root 2. On comparing with x cos theta plus y sin theta is equal to p, my perpendicular distance will be 4 root 2, which can be further solved as 2 root 2. My cos theta will be 1 by root 2 and sin theta will be minus 1 by root 2. As you can see that uh, cos is positive and sin is negative, it is in fourth quadrant. In fourth quadrant it can be written as 2 pi minus pi by 4. So perpendicular distance is 2 root 2, whereas the angle made by that perpendicular with the positive direction of x axis is 7 pi by 4. Let's try to understand the fourth question. Find the distance of a point minus 1 comma 1 from the line. The given line is 12x plus 6 is equal to 5, y minus 2. So 12x plus 72 is equal to 5y minus 10. So 12x minus 5y plus 82 equal to 0. So perpendicular distance of the point minus 1 comma 1 from the line 12x minus 5y plus 82 equal to 0 is, we know that formula, E is equal to ax1 plus by1 plus c upon square root of a square plus b square, right? This was the formula of perpendicular distance, right? So here 12 into, in place of x we will keep the x coordinate of the point, minus 5 into, in place of y I will keep the y coordinate, and the constant as it is, upon square root of x coordinate square plus y coordinate square. So that is minus 12 minus 5 plus 82 upon, you know that this is Pythagorean triplet, 5, 12, 13. So it will be 30. This will be minus 17, and 82 minus 17 will give you 65 by 13. 13 was the 13 5. So So the perpendicular distance of this point minus 1 comma 1 from this line 12x minus 5y plus 82 equal to 0 is 5 units. Let's try to understand the fifth question. Find a point on x-axis whose distance from the line is 4 units. So we have to assume let the coordinates of the point, required point, on x-axis be x comma 0. The given equation of line is x by 3 plus y by 4 is equal to 1. That is 4x plus 3y is equal to 12. 4x plus 3y minus 12 equal to 0. So perpendicular distance of the point x comma 0 from the line 4x plus 3y minus 12 equal to 0 is 4. It is given in question. So 4 is equal to mod ax1 plus by1 plus c upon square root of a square plus b square. That is 4 is equal to mod 4 into, in place of x I will keep x only, and plus 3 into, in place of y I will keep 0, minus 12 upon square root 4 square plus 3 square. I know the 3, 4, 5 is a Pythagorean triplet. So 5 fours are 20 is equal to mod 4x minus 12. Now if I want to remove this mod, then I will take one positive value and one negative value. So this will be 42 is equal to 4x, or x is equal to 8. And this will be minus 8 is equal to 4x. Therefore, minus 2 is equal to 8. Therefore, the required points are 8 comma 0 and minus 2 comma 0. Let's try to understand sixth question, where we are asked to find a perpendicular distance between the two parallel lines. So the given two parallel lines are 15x plus 8y minus 34 equal to 0, and 15x plus 8y plus 31 equal to 0. You can see that the coefficient of x and y is the same. If it is not, then you have to make it same by multiplying some numbers, because the coefficient will be in ratio if the given two lines are parallel. Then for the perpendicular distance between two parallel lines, the formula is mod c1 minus c2 upon square root of a square plus b square. Here if I see, then my c1 is minus 34 minus c2. c2 is 31 upon square root of 15 whole square plus 8 whole square. Right. So this will be minus 65 whereas you know that 8, 15 and 17 are Pythagorean triplet. So here you will get 65 by 17. Right. Here in second subquestion, the given two parallel lines are Lx plus Ly plus p equal to 0, and another is Lx plus Ly minus r equal to 0. So perpendicular distance between two parallel lines is equal to mod c1 minus c2 upon square root of a square plus b square. So this will be mod c1 is p minus c2 is minus r upon square root of a square, that is l square plus b square is also l. So l square plus l square will be 12 square. So mod b plus r upon, I can write this as root 2 mod l. So finally I can write this as 1 by root 2 mod b plus r upon l. Let's try to understand the seventh question, where it is given that find the equation of a line parallel to the given line 3x minus 4y plus 2 equal to 0 and passing through point minus 2 comma. So the given equation of line is 3x minus 4y plus 2 equal to 0. So slope of given line is equal to minus a by b. You can find the slope of any line using this formula minus a by b, where a is the coefficient of x and b is the coefficient of y. As my required line is parallel to given line, slope of the required line will be the same, 3 by 4. You know that two parallel lines will have same slope. Required line passes through point is given minus 2 comma 3. So using point slope form, equation of line will be y minus y1 is equal to slope into x minus x1. Therefore y minus y1 is 3, whereas the slope of line is 3 by 4. X minus x1 is minus 2. If I cross multiply, then 4y minus 12 is equal to 3x minus minus plus 3 2 are 6. Therefore 3x minus 4y plus 18 equal to 0. This is the equation of a required line.